afternoon, everybody. This is Eric Dunn, National Account Manager for Johnson Controls at Alps Controls, and welcome you to a webinar that's going to focus on a company called Vaisala. In a marketplace that's crowded with manufacturers of sensors, it's refreshing to see a market leader that has proven products, innovative approaches, and a solid reputation. So Vaisala is a company that manufactures devices for measuring humidity, temperature, and weather when data is critical. They boast over 1 million sensors manufactured every year, over 2,000 employees around the globe, 89 years of innovation, and interestingly enough, they're the only company like this that has 2 planets with their technology and operation. Maybe Luke can tell us more about that in a minute. So remember, reliable measurements into trustworthy data is what Vaisala is all about. So we'll focus today on humidity, temperature, and weather measurement devices. About 20 or 25 minutes of presentation. And I want you to know that you can ask questions at any time during the presentation by using the chat feature at the bottom. Submit your questions and we'll have a Q&A at the end. So I'm going to turn it over to Luke. Luke?
Sure. Thank you, Eric. So first, I want to thank everyone for taking the time to listen to this webinar. Today, we're going to go over some humidity, temperature, and weather instrumentation, like Eric mentioned, and we'll also touch on some details on specific technologies that we use, as well as a few different applications. So first, a little bit about myself. My name is Luke Cava. I work on our industrial instruments and applications team. So I've been with the company for about 3 years now, and I specialize in industries like HVAC, data centers, and life sciences. So we work with lots of different types of customers, most of them being engineering firms, contractors, and building designers. And my team specifically, we assist with ensuring that product specifications align with application requirements. So essentially that our products are going to perform how our customers need them to. So as I mentioned, I work on our inside sales and applications team. So along with myself, I work with 7 other people that cover the industrial instruments, and we support the US and Canada. So I will also do a little bit background of some people you may have worked with previously if you're familiar with Vaisala. So Maria Usma is head of industrial sales North America. So she's been with Vaisala for over 20 years now, previously with our office in Finland, and then the past 3 years heading our sales team here in the Boston office with me. Dennis Jonio is one of our sales managers. He specializes in partner management as well as business development for data centers in North America. And then Catherine Walsh is our channel partner manager who specializes in larger key account management. So first, a little bit of background on Vaisala specifically. Vaisala was founded back in 1936 in Helsinki, Finland, where we are still headquartered today, by Professor Vilo Vaisala. Vilo Vaisala was a meteorologist by trade. So as you may have guessed, that translates to Vaisala began mainly just as a weather company. And then recently, in the past 50 years or so, we've transitioned into a more industrial application. So Professor Vaisala was producing more than 100 papers and then 10 patented inventions over his time, with the most notable one you'll see here in this picture being a radiosonde. So a radiosonde is a small device that's used to measure weather conditions in the atmosphere when it's attached to a weather balloon. So those get sent up into the atmosphere and they log or transmit data that can be used to weather forecast as well as do some atmospheric research. So shortly after he productized and finalized that design, he founded Vaisala, and that became the first product in Vaisala's offering. And then our first customer was actually, the first products were sold to MIT for research purposes, and that was the beginning of Vaisala. So from where we went to where we are now a global company. Eric mentioned we are also on 2 planets. So we like to include that fun fact in all of our presentations, but our instruments are actually measuring humidity and pressure on Curiosity and Perseverance Mars rovers. So that was about 5 and 10 years ago, I believe. But now we operate 24 offices in 17 different countries with almost 2,500 employees. Our largest site is still where we began back in Finland in our Vantaa office. So Vantaa is just north of Helsinki, the capital, in a suburb, and that's where 2/3 of our employees are. So this is home to our factory. This is where we manufacture all of our sensors, and we also have our R&D and innovation center. We have a few other large sites. Here in Boston is where I'm based. We have a large service center that services all of North America, so US and Canada. And then we also have our Boulder facility, which is home to most of our weather team of the US. So this is just a picture of our Finland campus over in Vanta. So this is a pretty impressive campus. It's 4 different buildings. What you can't see here is that all of these buildings are actually connected by underground tunnels. So I don't know how many of you are familiar with the winter weather of Finland, but it's nice when you have meetings in different buildings, you don't actually have to travel out in the snow. You can travel underground and get to your next meeting. So figured I'd show you guys that. And then this is the last slide before we get into the real information, but I want to highlight this before we dive too far into humidity and temperature and include this slide to showcase the offering of the parameters that we have for measurement solutions. So humidity and temperature are our main and most commonly measured parameters. However, we also have sensors for dew point, vaporized hydrogen peroxide, carbon dioxide, moisture and oil, barometric pressure, weather and wind, which we will touch on briefly, methane and CO2 for biogas, and then a full line of calibration services for all of our instruments as well. So I'm happy to answer any questions on any of these. However, today's information will be mainly dedicated to humidity along with outdoor weather measurement. So just a brief agenda so you know what we're going to go over today. I'm going to start with our HumiCap sensor technology, and then I'll go into some of the actual hardware available in our offering and what makes our sensors unique. And then along the way, I will touch on topics like selecting the correct instruments, why high quality measurements are important, and then a little bit about calibration and adjustment as well. So getting into it, the HumiCap sensor is what we base all of our moisture technology off of. So the HumiCap sensing technology was invented over 50 years ago, back in 1973, and it was the first solid state humidity sensor. So it's a capacity thin film technology that senses moisture through a polymer and using an upper and lower electrode. So previously, before it was solid state, humidity was actually measured with hair hygrometers. So that actually used human hair. So if anyone has ever had a bad hair day when it's very humid, you should know that human hair actually changes length up to 3% of its length from a scale of 0 to 100% humidity. So that is the reasoning behind that. But we used to put hair in between 2 posts, and then that length would be directly representative and could be measured to calculate relative humidity. So now our new technology works like this. So you have an upper electrode, a thin film polymer, a lower electrode, all stacked on top of a glass substrate. So the water vapor penetrates through the upper electrode and is absorbed by the polymer. And then how much water is absorbed is actually dependent on the ambient relative humidity. So when that water gets into the polymer, that changes the dielectric properties of the sensor. And then we can actually measure the capacitance between the 2 electrodes and calculate the relative humidity, as well as several different moisture parameters. So the benefits of using this, as opposed to the early days hair hygrometers, is that they're much smaller. So that small size, so you'll see on the left is actually a wafer chip. So we produce our own humidity sensors. That chip has about 100 sensors on it, and then they are cut into pieces and then integrated into our instruments specifically. So they're much smaller, allows us to do a lot more with them, and also offers a very fast response time, with our T63 response time being about 15 seconds. And then with that, we've also been able to integrate specific technologies such as chemical purge, sensor pre-warming, all of these things allowing us to make these really chemically resistant as well as corrosion resistant. And then they can mitigate things like condensation, specific chemicals, cleaning agents, all to make sure that they're stable and giving good readings over time in their lifespan. So as I mentioned earlier, this is the basis technology of all of our moisture measurement in our sensors. What we do is we either update them or we strip them down a little bit, maybe to make them low cost or more low cost than some of our high-end precision instruments. And then we integrate them into the probes or the sensors specifically. So getting more into our instruments, we have our 1% humidity spec. So if you saw on the last slide, we do specify below 1% or plus or minus 1% humidity down to 0.8% RH. That is in pretty much perfect condition. So room temperature between 40 and 60% humidity, you can actually get below and more accurate than 1%. Typically, it will be 1% from 0 to 90%, and then 2% from 90 to 100% relative humidity. So these are our high-end products. And what we have here is a lineup of different types of probes that use the same technology, but they're designed for different purposes. And what I would like to highlight is that while we do, by nomenclature, we call these humidity and temperature probes, with humidity and temperature, we're actually able to calculate several different parameters. So these alone can calculate up to 16 different moisture parameters, whether it's dew point, mixing ratio, wet bulb temperature, anything like that, enthalpy. You can get all of those outputs directly from these probes without actually doing any conversion yourself. So starting on the left, I'll highlight that. That's our fixed probe design, the HMP1. So that's great for room, wall mount, anything that's not rated for washdown but still needs high accuracy. And then moving along, everything else is rated for washdown except that HMP9 on the right. So similar design, but we have the HMP3 still integrating with the humicap sensor, but has a cable itself and has a higher temperature rating. And then down the line, we have specific probes for high pressure and vacuum environments, high temperature environments in the HMP5, high humidity environments in the HMP7. And then the HMP8 is actually pretty unique because it offers an adjustable insertion depth. So it actually has a threaded fitting there that slides along the length of the probe. And it also can be used with a ball valve kit. So that alone has the high pressure rating, not as high as the HMP4, but it has a high pressure rating up to 40 bar, and then has a high temperature rating up to 180 degrees Celsius. And then lastly, on the right, we have our smaller sensors. The HMP9 is designed with a very fast response time, and then that TMP1 is temperature only. So these all come with traceable calibration certificates to ISO 9001 compliance. And that's done at the factory as standard and will come with a certificate when it's delivered to you. So these on their own can operate with a Modbus RTU protocol in terms of data transmission. That can be used with the M12 connection that is on each of these probe bodies. However, if you were looking to have, say, an analog output or you wanted to see a display readout real time, you could pair these with our line of Indigo transmitters. So these are all of our permanently installed transmitters. I also will highlight our portables later on, but I'll actually move from right to left here. These white boxes here, you will see our Indigo 200 series. That consists of our Indigo 201 and Indigo 202 transmitters. The Indigo 201 offers 3 analog outputs, a display and non-display version, and is also configurable through a USB. And then the Indigo 202 is really more of just a display because its outputs are Modbus RTU over RS-485. So it's the same as the probe, but it would be if you wanted to have a wall-mounted display, and so you could see those readings real time rather than seeing them back at your controller. In the middle there, we have our Indigo 300. This is actually a later release than the rest of the series, but we saw a market for a smaller metal enclosure. So we developed this a few years after the original Indigo release. So what's unique about this compared to the other ones is that it actually comes with analog outputs pre-configured from the factory. So this is similar to the predecessor model, where you don't actually have to do the configuration like you would with the Indigo 200 or Indigo 500, which I'll touch on in a second. But you can just provide power, connect the probe, and then you're ready to go. All the outputs are already set up and configured for you from the factory. So over on the left, we'll see two that look pretty similar. That's our Indigo 500 series. The left being the 520 and the 510 being what we call the little brother. So the Indigo 510 supports one probe. It does have a touchscreen display, and you can configure any analog outputs, any settings through that display. It would not be pre-configured from the factory. Along with that, you get an Ethernet connection that supports transmission of data through Modbus TCP/IP, as well as internal data logging that can be accessed through that remote web interface through that Ethernet connection. So one more step up, we have our high-end Indigo 520. So this is our top of the line Indigo transmitter. It has 4 analog outputs. You'll see it can do dual probe support simultaneously. So if you need to measure in 2 different locations, you can connect 2 probes to this one transmitter. It does have options for PoE as well as that Modbus TCP/IP protocol over Ethernet. along with that remote web interface and data logging capability that comes with the Indigo 510 as well. So here are a few installation examples. So over on the left, we have the HMP3 probe with the Indigo 200 non-display model. So you'll see there's a remote probe cable in between the transmitter and probe. That's just a female to male adapter if you need some extra probe length. You'll also see in the bottom middle of this diagram down here, you can also connect that probe body directly to this locking wheel if you wanted more of a fixed design without that intermediate probe. In the middle, you have the Indigo 520 supporting two probes. That's actually our CO2 probe, the GMP 251, but we won't touch on that much, but it does do dual probe support. And then on the bottom of that transmitter, you actually see this piece right here. That's a filter that covers the barometric pressure barb fitting. So the Indigo 520 can also be outfitted with a barometric pressure module if you were to say need that in like a lab space or maybe even outdoors. On the right here, we have the Indigo 510 with the HMP1 wall mount with this wall mount bracket. And then on the bottom, we have this weather station. I'm going to touch on this later in the presentation, so I will not get too far into that now. And then I wanted to highlight this Indigo 300 with the HMP1. So this is a true wall mount fixed probe design. This is what a lot of people like to see when they see wall mounts. They don't always want something like this Indigo 510 with the cable that's required in between. And then on the bottom left, you'll see our duct mount kit that is compatible with the HMP3 and HMP7. It's designed for that 12 millimeter diameter probe that allows you to penetrate within the duct, run the remote cable down to your transmitter that's wall mounted, and then that ball valve that I mentioned earlier that's compatible with the HMP8 that allows you to hot tap into systems and use that adjustable insertion depth that the HMP8 has to offer. So moving along in our products, so this is our line of plus or minus 1.5% humidity. So not as accurate as those HMP X probes, but still on the high end side. These still come with traceable calibration certificates to ISO 9001 compliance. Just a bit of a stripped down design of that humicap sensor that doesn't have the same chemical purge option that we would have here. So on the left is one of our most popular items that we see used in every industry pretty much. It's our HMT 120 and HMT 130 series. So this is a sleek transmitter. It's great for clean rooms because it doesn't have any screws or crevices where it would be hard to clean. It can also be installed with a fixed probe or a remote probe if you need to be duct mounted versus a wall mount. And then we also have options to add a radiation shield for outdoor installation and then that flange for the duct installation. Moving over to the right, we have the HMD 60. Similar specifications, just a metal enclosure that will be suitable for IP65 conditions in duct kits or in duct installations. And that features a long probe standard version as well as a shorter probe for smaller duct diameters. And then all the way on the right, I'll skip over there. That's actually the HMP 110 and HMP 113 probe. That's the probe that's specifically used with the HMT 120. So that's a removable probe that can be calibrated separately. So if you ever do need to service things and you don't want to shut down your process or pull it out of your system, you can keep spare probes on hand that are calibrated and you could swap them into your HMT 120 and then send that one out for calibration or calibrate it yourself while the other one is in place taking measurements. And then right there in the middle is a newer offering for us, but it's a temperature only probe with the TMP 115 you'll see in the thermal well at the bottom. That's designed mainly for freezers, chambers, and liquid nitrogen tanks. So that can go down all the way to minus 80, minus 200 with the TMP 115. Some of them are only calibrated down to minus 90. Continuing along with the offering, this is a little bit different. It doesn't offer any remote probe options or cables or removable probes. But we have our HMW 90 series, so we refer to it as the 90 series. You'll see on the right, we have a temperature only model. So this is great for warehouse monitoring, rooms, lab spaces that don't need washdown rating. So this is only IP rated, whereas everything else was either IP65 or IP66. They do still come with traceable calibration certificates, ISO 9001 compliant. The difference here is that we actually don't adjust or calibrate these. They come with a replaceable humidity and temperature module that comes with its own certificate. So that can be changed in the field by anyone. It's shown right here as the HMT 10. This is just the module that houses the humidity and temperature chip. That can be pulled out and put right back in, and then pulled back into spec to get back to that plus or minus 1% humidity rating. One thing that's unique about these is this decorative cover you'll see. So a lot of these are used in museums or say spaces where you don't necessarily want to see the transmitter itself. Museums tend to think these don't fit in with their maybe artwork or anything. We like the look of them, but if you want to hide them, you can insert a either wallpaper or you could paint this. But you'll see on the right here, if you look closely, you can see that square and it's reading behind that, and it's actually ventilated, so it gets good airflow and can get a good measurement still, even though it might not be visible to everyone around. So continuing down the line, we have our plus or minus 2% humidity sensors. So these are still no remote probe, but we have the option for wall mount and also for duct mount. Still the humicap sensor, still traceable calibration certificates. Here you'll see that we actually have a specific model all the way on the right for outdoor measurement. So this features the radiation shield, and I will touch on this later, but the radiation shield actually has a specific design that allows airflow in, reflects sun and elements away, but then the bottom you'll see on this bottom right picture is painted black. The reason for that is so sun gets absorbed and not reflected up and heats up that space and creates a bit of a microclimate that would mess with the measurements of what you see. This duct-mounted probe still offers the adjustable insertion depth, so you have one probe length, but this finning piece will allow you to move the probe in and out for different size duct diameters. And then over in the middle on the right is a probe that's been, or a transmitter that's been gaining some traction recently in the data center market. This is our TMI 110 immersion temperature. So it's designed to measure temperature in liquid with a thermal well. So with the move to liquid cooling from air cooling, as a lot of data centers are going, this is a way to measure within your liquid lines to confirm temperatures and control off of. And then last but not least, this is our plus or minus 3% relative humidity range. You will see the big red X on the right. So that means that these do not come with a traceable calibration certificate, but they are still spec'd at plus or minus 3% relative humidity. They use the same housing as those 2% HMDW 110 series. Excuse me. So the same housing, same setup. The big difference here is that they use our intercap sensor as opposed to our humicap sensor. So as I mentioned before, everything is based off the humicap thin film capacitive technology, but the intercap is a very much stripped down version that actually doesn't require calibration. If you wanted to change the sensor, this is the benefit of the plus or minus 3% series. If it tends to drift over a couple of years from 3 to 4, maybe even 5%, and you want to pull it back into spec, like I showed you the picture of the graphic of the humicap, you can pull out those two prongs, plug the intercap sensor that you purchased as a spare part back in. No need for calibration, no need for adjustment. It just drops you right back down to that plus or minus 3%. So highlighting our outdoor air offering, I'd first like to touch on what it means to be a weather station. So we get a lot of different customers that say, hey, I need a weather station. And my first question is always, okay, what parameters are you looking to measure? And that can mean relative humidity, that can mean temperature, that can mean I want to measure something like the WXT530. The WXT530 is a full weather transmitter. It does wind speed, wind direction, rainfall, snow, barometric pressure, and humidity and temperature. Some people say I need a weather station. They just need the HMS 80 or the HMS 110 series, which is just humidity and temperature, maybe a dew point reading. So weather station is used pretty interchangeably in these industries, but a lot of times they maybe need something more basic or something a little more complex like the WXT530. So over on the right here, you will also see the HMT 120. This is the offering that includes the rain shield for the transmitter that just has a little lip over to guard from any rainfall pooling or anything like that. And then again, the radiation shield. And then over all the way on the right, we have the Indigo 500 with the meteorological mounting kit, the Indigo 500 MIK. This will be highlighted in the next few slides. But I wanted to just make note that the common theme between all of these is the radiation shield. You'll see it on each of these instruments. That's a recommendation that we will always give if you're installing any of our transmitters outdoors. So for the WXT530 series, this is a pretty wide offering. So you go from on the left, more basic, where it's just measuring precipitation, to on the right, the WXT536. It's precipitation, wind speed, wind direction, everything that I mentioned previously. So depending on your needs and what parameters you're looking for, you can go really on the high end with the WXT536, or maybe you just need something that's doing wind speed, wind direction, and precipitation like the 533. So along the bottom, we have some installation accessories. These are typically mounted high up on a pole. You don't really want them wall mounted because if it sensing wind, it will often obstruct or block any elements. And then in the middle, we have the bird spikes. So that is because the precipitation sensor is heated to melt any ice, or that's the purpose of it. Many birds think it is a nice warm place to build a nest. So we include bird spikes as an offering, which I will always recommend to anyone that is utilizing the heating. We also offer surge protectors, and then these typically operate using an RS-485 Modbus output or a different digital interface. We also offer an analog output converter, as well as Initech we have a relationship with, and they make a backnet converter compatible with the WXT530. And then here's that Indigo 500 MIK I mentioned before. You'll see the Indigo 520 right in the middle. That could be the Indigo 510, but the 520 makes a little more sense as it has dual probe support. In the left, this is typically a humidity and temperature probe, and in the right is for the warm probe enclosure. So the reason it's a different shape is because I mentioned this earlier, but if you have a heated probe, like the sunlight was heating up that environment, if a probe is artificially heated, it might heat up that radiation shield and cause a microclimate where it's going to mess up the readings because that temperature is being artificially warmed and changing any of the temperature dependent parameters. And then here on the bottom, we have our SPH20 or SPH10 in this case. This is a static pressure head. What this does is it mitigates any wind noise or wind interference and allows you to get a stable barometric pressure measurement. Moving a little more into the Indigo platform, I'm getting towards the end of my slides here, but I wanted to highlight the Indigo 80. So I had measured, it's over here on the right, this is our portable option. I had gone over our offering of probes. So all of these different parameters can be measured with the Indigo series transmitters. The Indigo 80, however, is an option that is a portable solution. So that can be great for spot checking, any sort of data logging, short-term data logging, and any portable measurement that you might not want to have a permanently installed sensor. And it can be paired with so many different probes, which makes it so valuable. It also has that dual probe support that's similar to the Indigo 500. It can log up to over 5 million data points, and then it can also give you a numerical and graphical display. So once that data is logged, you can connect it to a PC. It's exported as a CSV file, and you can analyze it within Excel, which makes this very unique. And it's also great. It can actually connect to probes and bring you through a guided calibration if you were going to do the adjustment yourself. If you weren't looking for something so robust and technologically advanced as the Indigo 80, we also have the HM40 series. I figured I'd highlight this because I believe there's going to be a raffle at the end for one of these. So a little details about these. These are still high-end accuracy. They're plus or minus 1.5%. The indicator stays the same through all the probe options. However, it's a little bit stripped down. You don't get the same data logging. You don't get the dual probe support, but it is a great portable reference. It comes with that traceable calibration certificate. So if you ever are doing any adjustments or calibrations yourself, this is a great option for a reference meter to use. And then just to highlight this, if you ever are interested in doing your own calibrations, we have an HMK 15 salt calibration kit. So how this is used is we offer 5 different calibration salts that create reference environments, anywhere from 11% to 97% humidity. This salt is mixed in a chamber with deionized water, and it produces a known reference value. So typically we see 2-point calibrations, so say 11% and 75% relative humidity. You can connect to a PC or that Indigo 80 handheld, calculate your reference environment, and then make the adjustment of the probe you're looking to adjust. The reason we recommend keeping a portable on hand is that while we expect these to be exactly 11% or exactly 75%, a lot of times when you mix them with the water and they're sitting in the chamber, it's not a controlled environment out in the field, so you'll get an 11.1, 11.3% reading, or maybe even a 75 or 74.9, something like that. So this having that reference meter offers you a traceable accuracy level, so you can adjust to that 74.9 or that 11.3 instead of just adjusting to that 11%. So it makes your calibrations and adjustments a little bit more accurate. And then if you're not looking to calibrate yourself, you just want someone else to take care of it. I mentioned before, but we have a full calibration service lab here in Boston. We service all of the US and Canada, and we can do any of our products. If you do know beforehand that you're looking to calibrate at a known time, say once a year for the next 3 years, you can purchase a calibration care agreement. So what that offers is you're immune to any price increases. So you schedule out your calibrations for all of your instruments, and then Vaisala covers all the shipping. You skip any of the queues, so you're getting your instruments back faster, and which streamlines the whole return process. So that's something to note if you're ever purchasing from us. We love working with those people, and our service business is a big part of our business that we're really proud of. And this here's my last slide. I just want to highlight our contact information. But again, I think we're going to open it up to the Q&A now. So if anyone has any questions, thank you for now, but appreciate your time.
Great. Thanks, Luke. This is Alan Lopazinski, the Director of Marketing at Alps Controls, and I'm just going to be reading some of your questions here that we have in the queue. We have one person who wants to know, when is the right time to use a portable instrument versus a permanently installed instrument?
Yeah, sure. So that's a great question. A lot of times I see portable instruments as a great resource for spot checking or calibrations, like I mentioned, but it could also be if you're not too sure exactly where in your process you're looking to measure. So if there's a couple different points in your process, a portable is a great point to see, okay, should I measure in the middle of the room, or do I want to measure where the air is being pulled in? What's the most valuable if it's doing demand control ventilation or something like that? Maybe you want to try something out with a portable before you drill a bunch of holes and put in all the screws and make it so it's a little bit harder to move.
Luke, I had a Johnson employee in the Carolinas order one of your portables a while back, and I called up to see what was the application, and he said, "Hey, I deal with these commission agents all the time, and they go in there and they have their handheld temperature, humidity measurement devices, and they're telling me we're off. What's displayed is in the BAS is not what's in the room, and we've got to scramble to verify our measurements." He goes, "With this, I can walk right up, and I've got something that's NIST, it's traceable, it can be calibrated, and I can tell them your device is off." So, and that's where the measurement is critical. So in this case, it's not a safety issue; it's just a harassment issue. The commission agents a lot of times come in like, "Hey, you're off. You're off 3 degrees." It's like, well, no, we're not. And he can come right up with your device and get a true measurement because it's traceable, it's certified, it's calibrated, and then the name stands behind it too. So he's got something that is on par with what the commission agents use.
Yeah, that's a great point, especially because our portable offering, we offer that high-end accuracy. So most of the time it's spec'd at a higher accuracy or at least the same accuracy as the instruments that are permanently installed. So it becomes a great resource to ensure that you're actually getting good readings.
Okay, we have a question from Cal Clendenin. He would like to know, I might have missed this, but I was wondering if any OATH sensors come with IP Internet Cat6 connections.
We don't offer Cat6 connections, so we do have integrations that allow you to communicate over BACnet or over an IP communication, but Cat6 is not something in our offering. I think, in my experience, it's a bit of an older technology, so we don't see it too often. But if that's not the case, I'd be happy to talk to product management and see what we're able to do if there's a market for it.
Hey, Cal, if you want a BACnet IP application from any of their devices, there's a question I submitted earlier, but we'll address it now. We can get the Modbus registers from Vaisala most likely and do a gateway, like a field server gateway, and do that to BACnet IP for you. Whether the gateways are IPv6 or not, I don't know, but we can get at least BACnet IP or BACnet MSTP for you on all the Modbus devices. Okay.
Yeah. Anything that's Modbus, we have full register maps of what parameters are pulling from where. So you can do a lot of conversions or use the gateway. And I think Alps is pretty comfortable with that as well.
Okay, we have one person who wants to know what is the recommended calibration interval for humidity products?
So that's a tricky question. We actually don't specify a specific interval for our products. We recommend every 1 to 2 years, but that's kind of a soft recommendation. The reason for that being is that any form of drift in a sensor is really directly related to where it's been installed and how often it's been used. So if you ask me how often do I have to calibrate this wall-mounted room sensor that's in my office, that's in a controlled temperature that's typically between 65 and 70 degrees and 40 and 60% humidity, you may never have to calibrate it. It'll probably read within its specified accuracy for 5 to 10 years without a problem. However, if you have a space that's seeing outdoor conditions, maybe it's been cleaned in a laboratory or something and it's got cleaning agents off it, we have those technologies that I mentioned, like the probe warming, the chemical purge that will help it to stay in tolerance. However, you might be more benefited from calibrating more often. So that's a long answer. The short answer being we recommend every 1 to 2 years. If you have a more extreme condition, we actually recommend maybe before 1 year. The benefits of sending it back to us with calibration, though, is we do your first calibration and we will give you the as found and as left data. So say you send it back in a year and you get your transmitter back and it says, oh wow, it didn't actually drift as much as it's I thought it did. Maybe you send it back in 2 years after, or you get it back and it say, oh, it came back and it drifted way more. Maybe I want to calibrate these every 6 months instead. So there's a method to it, but as you do that over the lifespan of the sensor, you can kind of gauge the specific calibration interval that you need to meet your quality specs and to meet your process conditions.
Okay, we have one person who would like to know, can you please share the presentation file because a few of his team members were unable to attend? I can probably answer that off the top of my head. We're recording this right now, and so we will put the whole presentation, the whole show onto the Alps Controls YouTube channel, and Eric will have that link to be able to send it out to anybody who needs and wants it. So that will be ready probably early next week. We have another question here. Are there benefits to controlling an HVAC system on different moisture parameters than relative humidity?
Yes, actually, a lot of HVAC control systems typically run on dew point rather than relative humidity if you're controlling the moisture level in the air. The reason being is that relative humidity is dependent on temperature. So when you have varying temperature, whether it's an outdoor space, a process environment that's going to be varying in temperatures in a wide range, when you try and control on humidity, it leaves this large gap where if the temperature changes significantly, the relative humidity changes significantly as well. Whereas if you control off something like dew point that's temperature independent, that moisture reading, that dew point level, even if the temperature jumps or spikes quickly, you still get a flat reading. So it allows your HVAC system to work a lot less because it's not trying to keep up with these changes in humidity that it's seeing when it's measuring relative humidity.
Are there any common mistakes that can be avoided during installation?
I definitely have a few. I'm sure Eric might have some too, but the one that I see the most is installation location. So a lot of times we get questions of where's the best spot to install this sensor, and similar to the question about calibration interval, it's not always one answer fits all, but what we tell people is that we want our sensor to be in a location that gives you a measured value that is representative of the space you're looking to measure. The issue that we see a lot of times is when you, for example, I use room sensors. If you install that room sensor near a window where there's light coming in, and in the summer it's just getting cooked, and the temperature sensor is in a spot that's 90 degrees, even though the space as a whole is 70 degrees, and you're controlling off of that specific sensor, your HVAC system is going to be so confused and it's just going to be pumping in cold air because it thinks it's 90 degrees in your space just because you installed it in front of a window. Similar to that, I've seen people wire sensors through the wall and they don't actually seal the gap for the wires. And then you get cold air through the wall flowing in right next to your sensor, and that can bring your readings off as well. So installation location is probably the biggest mistake that we see. But typically, if you question us first or send us pictures of your installation, we can guide you in the right direction. So things like that don't happen.
AW Wayne Griner would like to know if doing conned weather, or excuse me, if doing conned water temp optimization need WB.
I'm not exactly sure what that. I don't know what conned water is. That's not
Condensing water loop, probably.
condensing water.
Yeah.
So what was the question again, Alan? Maybe you could repeat that.
Sure. It says if doing conned water temp
Condensing water
optimization need WB.
need what?
Bulb. I might have to do some research or maybe get some more context there. I'm not familiar with the process of doing condensation water. So that might not be a question I can answer right now, but I can definitely get back to you and see what I can find.
Okay, maybe if Wayne's still on the line, he can give us some clarification on what he's looking for there.
Yeah.
Sorry if I butchered up your question there, Wayne. We have one more sitting in our queue. Is there any concern with the accuracy of the sensors installed outside in a radiation shield due to limited airflow?
So I actually touched on this briefly. The radiation shield is designed specifically with those grates, so it allows rainfall and sunlight to be reflected away, or if it gets reflected off the surface, it gets absorbed by the bottom that's black. So there's never really concern with airflow. But on that, I will also add that our humidity sensing technology is its accuracy is not dependent on airflow. So the only thing that will change with increased airflow is response time. And that's really because you're getting more airflow over the sensor and the air is changing more. So your response time will respond faster. But in terms of accuracy, the way the technology works, where the water vapor is actually passing into the polymer itself, it's not increased or decreased by airflow. So our accuracy is independent from any airflow specification.
Excellent. Wayne has weighed in with a clarification. He says, just a comment. When using cooling tower temp optimization, use wet bulb and the cooling tower performance curve.
Yes, definitely. So yeah, I can, I guess, expand on that now. Thank you, Wayne. Yeah, a lot of people when they install, it's our HMS 110 series is often used for cooling tower control. They control off of wet bulb rather than relative humidity. So I think that was in reference to the question about when to control off parameters other than relative humidity that might be beneficial.
All right, excellent. That is all the questions that we have in our queue today. And so I'll thank all of our attendees for weighing in.
Yeah, thank you, everyone.
Awesome. And Alan, you said we're going to raffle off a HM46 to the attendees.
Yes, that's right. We're going to hold that raffle in the next day or so. We'll pick a lucky winner from all of our attendees and we'll notify you by email probably by early next week.
Great. And so for my Johnson friends, we'll share the link for recording on this, but if you need to see that or you missed it or whatever, please contact me and I'll share it with you. Thanks, Luke.
Of course. Thank you, guys.
All right.